So there is a catalog of misconceptions, but they're not all the same. They vary in terms of how easier they are to address, to dispel. And so this is somewhat of a taxonomy adopted from some researchers. So we see that misconceptions can be very easy to address when they are at the single proposition level, and they become progressively harder when they affect our whole mental model and beliefs that we have about how the world works. So let's attack them one by one. So at the very basic level, we have proposition level misconceptions. So for instance, the idea that we only use 10% of our brain. That is actually not true. It's a very seductive idea. There's a lot of movies made about people somehow figuring out how to use all of their brain, and then they acquire superpowers, they're invincible. That's actually not true. This is a very easy misconception to address because it's not tied to other things. It's something that people have heard, but when you explain where that number comes from, that it's actually 10% is the gray matter in the brain and 90% is the white matter, but it's not like we don't use the white matter or that it's just unhelpful, then that makes sense to people, and they can readily replace this new explanation with the old one. Things get a little more complicated when we go to other levels. So, for instance, when we're asking students to replace a mental model that they have, which is flawed, with a better one, a more useful one. So let's think about a model for blood circulation. Some students have a misconception that there is a single loop where all the blood travels from the heart to the rest of the body and then it comes back to the heart. This model is predicated on the belief that the heart oxygenates the body. Now we know that that is not true. We know that there is a double loop. The heart pumps the blood into the body, comes back to the heart, and it gets sent to the lungs where it reoxygenates and comes back to the heart to start the cycle again. This is a little challenging because the model that students have is actually coherent. And when you mention lungs, students can treat that as just one more part of the body where the blood needs to be sent to by the heart, and not as a special organ with a special function in that process. So what we know about these kinds of misconceptions at this point is that they function first by accommodation. So students figure out early on that they have to accommodate, they have to include lungs when they talk about circulation to appease the professor, even though they don't really see what's so special about the lungs. And then only later on, if we force them to reason on the basis of their mental model. So if the function of the heart is to oxygenate the blood, where does oxygen come from? It comes from the air. We breathe it in. And so how does the oxygen get from the mouth and the nose to the heart? Now the model starts cracking because we don't see a clear connection immediately. It goes to the lungs from the mouth and the nose. Oh, so now you start seeing what's the special function of the lungs. So the strategy that we have found from the research is that in order to challenge flawed existing mental models, we need to make students reason on the basis of their models until they arrive to some kind of contradiction. And then they're ready to listen and adopt a new model.
A third category of misconceptions are what some call ontological miscategorizations. These misconceptions aren't based on flawed mental models, more like incorrect or incomplete metaphors. Let's explore this idea with an example. In the diagram, we see an electric circuit with two light bulbs. Currently, the circuit is closed, and both light bulbs are lit. What happens to light bulb B when we close the switch S in the middle of the diagram? Take a second and try to predict what will happen. If you thought of electricity as a fluid, then you might have said that light bulb B becomes half as bright. The argument goes that when you close the switch, half the electricity goes down the wire with the switch, leaving half for the wire with light bulb B. But that's not actually what happens. Now, I'm a mathematician, not a physicist, so let's talk to an actual physicist to understand the question and why the fluid metaphor doesn't quite work. This is Dave Caudell, a doctoral student in astrophysics here at Vanderbilt University. Dave, we've got some circuits in front of us here. Can you kind of walk us through this example and what happens when the switch is closed?
Absolutely. So when we have the switch open, you're basically completing a path from the batteries into the first bulb, and then out of the first bulb and into the second bulb, and then out of the second bulb to complete the circuit. So the potential has to be shared between these two bulbs. It has to travel through both these bulbs, and as you can see, these bulbs are kind of dim right now because they're kind of sharing it. When we throw the switch, what we've in effect done is we've short-circuited the first bulb.
Wow. Okay.
And now this bulb has all of the potential to itself, and the current coming out of this bulb has two potential paths to travel. It could go through the second bulb, or it could just complete the circuit.
Okay.
It's going to take the path of least resistance, and it's going to bypass the second circuit.
Okay. So that's pretty dramatic, right? So clearly the second bulb goes dark. It doesn't get half as bright. It goes dark. What's wrong with the water metaphor here? If I think of the water kind of going past the first bulb, and now it has this choice. Do I go down the closed switch, or do I go through the light bulb? I want to say half of it goes one way and half of it goes the other way. Why isn't that the right way of thinking about this metaphor?
So the bulbs themselves, if you want to use your fluid metaphor, you can think of them as sort of like a clog of a big thick filter in the pipe.
Yeah.
Where the water can go through the pipe, but it has to be forced through those filters. So when it comes...
that's because of the resistance provided by the light bulb itself.
Absolutely. Because the resistance from the light bulb itself, or any component in a circuit that has a resistance, the electrons are going to have to be forced through. And so there has to be some amount of work that's done on them. Now, when we close the switch, the electrons that's come out of this first clog, if you will, this first filter, has two paths to travel. It could either try to force its way through a second, or it could flow freely. So in your analogy, if you did have a split in the pipe and you had two pipes, and one of them had a big thick filter and the other one the water was free to travel, all of the water would take the free path.
Right.
Because there
Not
wouldn't
half
be...
of it, but all of it.
Yeah, there wouldn't be enough pressure left. There wouldn't be enough force left to try and force any of the water through the second pipe.
So in this case, the metaphor of electricity and fluid isn't necessarily a bad metaphor, but it only works if you account for resistance through this kind of filtering piece of the metaphor. So you have to kind of enhance the metaphor.
Absolutely. When I was first coming to understand how these components work, that's how I often pictured it, is sort of like a liquid of electrons that was zipping through the wire and traveling from point A to point B. So I can't fault that.
And so when working with students with ontological miscategorizations, one step that we might take is making them aware of the metaphors that they're using and where the metaphors work and where they don't. And so if you figure out that a student is using this water metaphor, that's helpful actually, because then you can help them refine it in a way that actually captures the situation better. Well, thanks, Dave. This was really helpful.
Oh, my pleasure.
And then we get to embedded beliefs, like the idea that we've seen that the Earth is 6,000 years old. Those are the hardest to eradicate, and in fact, we don't really have magic bullets for those. They're problematic because they're tied to other beliefs. If you start challenging that, what else do you have to challenge? So there's a mental domino effect that goes on, including the trust that you have in the people who told you that the Earth is 6,000 years old. And some students might not be ready to engage in that process at this point. So this would be the hardest of all the misconceptions.